So we've been talking about this tangent ratio, which is the ratio of a side opposite an angle in a right triangle to the side adjacent. Okay? There are two other ratios that we're going to talk about because, and we saw this with a couple of examples where we had to use Pythagoras first, not every question you can use the tan ratio. Okay? So we want a couple of others to use as well. So here's our right triangle that we've been working with. Tell me, what side is opposite angle A in this triangle? Little a. Which side is the hypotenuse? Little c. What side is adjacent to angle B? Little a. Because remember, this is the hypotenuse, this is opposite angle B, which means by default that must be adjacent. So you should be familiar with finding the names of those sides. And what we've done to this point tan. And the tan of an angle, say for example above A, is equal to the opposite side over the adjacent side. Or in the example above, the side opposite angle A is little a, the side adjacent to angle A is little b. Or we could have called them by their capital letters, BC over AC. So we've done that one. There are two new ratios we're going to talk about. And the first one is called the sine. But it's spelled S-I-N-E, but we just abbreviate it S-I-N. The sine of an angle. So for example, in the right triangle above, will be the side opposite angle A to the hypotenuse. Using the letters above, the side opposite angle A is little a over the hypotenuse, which you guys already told me was little c. Or if we want to use the capital letters, we would say BC over AB. So that's the cosine. Spelled C-O-S-I-N-E, but we abbreviate it C-O-S of angle A is equal to the side adjacent angle A over the hypotenuse. In the right triangle above, it'd be little b over little c. Or AC over AB. So how do we remember these? And I heard one of you say it. You use the phrase so on. What does that mean? It means sine opposite over hypotenuse. Cosine adjacent over hypotenuse. And this one we've been looking at for a while, tan opposite over adjacent. Okay? So now when we tackle a right triangle problem and we're asked to find an angle or a side, we have to figure out which of the three trig ratios we're going to use. And we call these the three primary trig ratios. And we're going to be focusing in on them this year, next year, as well as grade 12, but also in grade 12, we're going to learn three more. But we'll worry about that in grade 12. Okay. All right, so let's just, best way to do this is tackle some problems. So just as a kind of warm up, we've got this triangle DEF. We are asked to identify the side opposite angle D and the side adjacent to angle D. Which of the three lengths is opposite angle D? 5. Because remember, if you want to find opposite, draw an arrow out from the angle you're trying to find the opposite of, and you'll hit the opposite side. If you want to find the hypotenuse, draw an angle out from the right triangle, and you'll hit the hypotenuse. And then the third side will be the adjacent. So opposite angle D is 5 centimeters. What side is adjacent to angle D?
13.
Sorry? 12 centimeters. Next, we are asked to find the sine of angle D and the cosine of angle D. So all we're asked to do here, we're not asked to find angle D. We're just asked to find the fraction that's sine. So what side over what side in this diagram represents sine D? Remember, sine, so, opposite over hypotenuse. Opposite, 5 over hypotenuse, 13. Cosine of angle D is adjacent, which is 12 over hypotenuse, 13. And we can stop there, because like I said, we're not asked to find angle D. If you were asked to find angle D, you guys would be able to figure out how to go about doing it, which we'll do in the next example. All right, and we have another right triangle, GHK. We're asked to find the measures of angles G and H to the nearest tenth. Remember, tenth means 1 decimal place. Just remember that. Okay. So let's look at angle G first. We need to set up a trig equation. And your trig equation is always going to look like which one of the three trigs, then your angle, then a side over side. It's always going to look like that. And then you just solve it. All right, so here's angle G. We know these two sides, right? What side is this called in this right triangle? Opposite, adjacent, or hypotenuse? Hypotenuse. What's this one to angle G? Adjacent. Adjacent and hypotenuse mean SOHCAHTOA. Which one? Now all of a sudden everybody's quiet. Sine. Say. Oh yeah, like somebody says it like cosine. What, are you deaf? This is you guys yelling. Oh. And then when you're right, you're like, I said that. Okay, so the cosine of the angle G is equal to the adjacent, which is 6, over hypotenuse, which is 14. How do I get G by itself? How do I get rid of cos? Cos inverse, right? Because how did we get rid of tan? Tan inverse. So let's do cos inverse, which means I got a cos inverse this way. And this is where you take out your calculator. There's 10, so 1 decimal place. What did we get? 64.6 degrees. I would go about the same thing to find angle H. Except this time for angle H, actually I'll do it in blue. Here's angle H. What's the name of this side now? Opposite. But this is still hypotenuse. So we're dealing with O and H, which means which trig ratio? Sin or sine, yeah. So sine of angle H equals the opposite side 6 over the adjacent, or sorry, over the hypotenuse 14. And remember, we're just solving an equation here. So we just want H by itself, so we need to get rid of that sine inverse, to take it out. Whatever you do to one side of an equation, you have to do to the other. And I'm thinking you should get 25.4. I'm afraid I'm going to have to ask you now to think. How could I have found this angle without using trig? No, because we're finding an angle. A squared plus B squared equals C squared finds sides. Chat G.
And so you know that equals like one side with squares and
Okay, yes. These two angles must equal 90 degrees. Because this is 90 degrees and all three must be 180. So we could have just did, well, we could have done it two ways. We could have done 180 minus 90 minus this, and we get this. Or we could have just done 90 minus this. It's another way to find it. But you're not going to be asked to find it a certain way. Just wanted you to think about it a little bit. Okay, last example. So sometimes when we get trig problems like this, it's usually best to draw a diagram. So we've got a water bomber, and I'm no artist, so I'm going to draw a little water bomber. And it's flying towards a target site. So somewhere on the ground down below, there's a target site. And then this is the ground. The plane's radar shows that it is 8,000 feet from the target site. What that means is that the plane the 8,000 feet is there. Okay. The altitude of the plane, what does altitude mean? What's another word? Height. So the height, and remember height's perpendicular, vertical, is 5,000 feet. Notice we just created a right triangle. I am asked to find what's called the angle of elevation from the target site to the plane. Now, an angle of elevation is, let's say, you're standing on the ground. And you're looking up at some object. I'll just say a building. Okay. Well, when you look, if you look straight ahead, that's called the horizontal. Okay. If you look up to the top of the building, that's called the line of sight. This is the angle of elevation. I mean, elevation means lift or looking up. You know, so like if I'm standing here looking straight ahead, I've got a horizontal from my eye. If I decide I'm going to look up at the roof or at the ceiling, notice I form an angle of elevation. Okay. So the angle of elevation from the target site, that's the angle here. This is the angle of elevation. So that's a diagram of our situation. So we've got to figure out what X is, and obviously we need to use trig. Here's the angle I'm working with. Here's one side I'm given. Here's the other side I'm given. This side is relevant to this question. Now, what I need to do first is figure out which of the three trig ratios am I going to use. Because if I use this as my angle, what's the name of this side? Opposite. Okay, this is opposite. What's this side? This is hypotenuse. So that means I have to use sine. And now your angle. Well, what did we call the angle? What did we call it? X, because we don't know. Equals opposite side, which is 5,000, over hypotenuse, which is 8,000. And now that we've got that set up, we solve. We gotta get X, Y, and Z. So what do I have to do? I have to do inverse, sine inverse of both sides. Make sure I'm rounding it to what I'm asked to. I believe it says nearest degree, so that's the nearest whole number. So the sine inverse of 5,000 over 8,000 would give us 39 degrees down. Okay. So that takes care of that.